of truth. In this video, we are going to talk about some theorems relating to similarity. Right? And the first of them is called the side-side-side similarity theorem. Now, in the previous section, we talked about how a figure is similar, or two figures are similar to each other, if their angles are congruent, their corresponding angles are congruent, and their sides are all proportional. But for a triangle, it is possible to determine similarity with with a little, really on just triangles. Okay, so let me give you an example. Let's say, for example, that I have two figures here, two triangles, and I have an object here that is 4 units long, 5 units long, and 7 units long. All right, and I don't know anything else about this triangle, and I'll just call this triangle ABC. And then I have another shape. Let's say that it's a little bit bigger than this one. Okay, so it looks something like this, and we'll call this X, Y, and Z. And these lengths are, I don't know, 12, 15, and 21. Okay? So what this theorem says then is that if all three of these sides are proportional, and so then the two figures must be similar to each other. And so what you do is you list out the smallest sides of each triangle, or all the sides of the triangles in order from smallest to largest. So for the first triangle, the three side lengths are 4, 5, and 7. For the second triangle, the side lengths are 12, 15, and 21. Now, if we were to compare these proportions, 4 over 12, well, that's equal to 1/3. 5 over 15, that's also equal to 1/3. And 7 over 21, coincidentally, that is also equal to 1/3. So you see that the proportions of these side lengths are equal. Okay, so not the side lengths are equal. I want to emphasize that. None of these side lengths are equal, but the ratios of corresponding side lengths are equal. If you take the two smallest side lengths and combine them and take a fraction out of them, and if you take the medium side lengths and compare them, and you take the largest side lengths and compare them, then you have all equal proportions. So then what we can conclude here is that, not surprisingly, triangle ABC is similar to triangle XYZ. Right? And the order in which we write this the similarity statement matters. From A to B is the smallest length. So XY, from X to Y is the smallest length. Then from B to C, B here to C, is the second smallest length, or the middle length. And what matches up there is Y and Z. Y and Z is the second, or the medium length of the other triangle. So we don't know anything about these angles. Okay? We don't need to know anything about these angles. As long as the side lengths are proportional in a triangle, and this only works for a triangle, then it is sufficient for us to say that these two shapes are similar. They are the exact same shape, just different sizes. All right, so that kickstarts things off for us here on this lesson. Let's look at the next set of problems, look at the next video where we actually apply this to some particular